sketching angles in standard position, converting between degrees and radians, learning about what radians is, determining coterminal angles, solving problems of arc length, angles, and radius of circles. So a quick review of sketching angles in standard position. On a Cartesian plane, you can generate an angle by rotating a ray about an origin. The starting position of the ray along the positive x-axis is the initial arm of the angle. The final position after a rotation about the origin is the terminal arm of the angle. An angle is said to be an angle in standard position if its vertex is at the origin of a coordinate grid and its terminal arm coincides with the positive x-axis. So thinking about this from Math 20, this is our initial arm. Here's our terminal arm. We are rotating this angle, and this would represent our angle in standard position, or sometimes refer to it as a rotation angle. So quick review from Math 20 with positive angles, but in 30 we rotate in both directions, so positive and negative angles. So quick reference, right? This would represent 0 degrees. This is 90, 180, 270, and a full rotation would bring us back to 0, which is 360. So if I wanted to sketch a rotation angle or angle in standard position of 70 degrees, occur somewhere in quadrant 1, where this rotation would be 70 degrees. Okay, and we definitely want to show this rotation now just to determine which way we're rotating, because that determines our positive or negative angles. So an angle of negative 210 degrees means we are now going to rotate in the opposite direction. So we're now going to rotate counterclockwise. This would now be negative 90 degrees, negative 180, negative 270, and negative 360 would be our full rotation. So negative 210 would be past 180 approximately, and the rotation, we're always rotating from 0 to here, would be negative 210 degrees. Positive 330 would occur somewhere between 270 and 360. So positive, we rotate in the counterclockwise position. And then finally, like negative 145 would fall between the negative 90 and negative 180 position. Somewhere here. All right, so that is a review on angles in standard position. Okay, from there so for each angle in standard position, there is always a corresponding acute angle called the reference angle. The reference angle is the acute angle formed between the terminal arm and the x-axis. The reference angle is always positive and 90 degrees. So if we were to go back to this, our sketch, identify the reference angle for each angle in standard position above. So going back to our example, this first example, this angle between the x-axis and the terminal arm is called our reference angle. So in the first quadrant, our reference and our angle in standard position is actually going to be the same. So our reference angle would be considered to be 70 degrees. For question B, even though this rotation is negative 210, my reference angle would be represented by this angle in here. So if I take 2, and it's going to be positive, so I take 210 and subtract this 180, that will leave me with my reference angle, which should be 30. And then C, my reference angle should be here between the x-axis and my terminal arm. So if I take a full 360 degrees and take away 330, that will give us our reference angle, which in this case would be 30 degrees as well. And then finally D, our reference angle here, again, is between the terminal arm and the x-axis. I would take negatives aside, 80, and I'd subtract the 145, which would give me this reference angle of 35 degrees. Okay, so that is a review on reference angles. Okay, so far in our math career, we have always measured angles in degrees. Today we are going to introduce radians. So like meters and feet can both measure length, degrees can both measure angles. If no units are written, then radians will always be assumed on full circle. Okay? Okay, so as an investigation, convert the following angles in degrees to radian mode on your calculator. So on your calculator, it'll actually convert these values for you. So let's just do the first one of 135 degrees. So if I wanted to convert to radians, my mode needs to be in radian mode. And then I'm going to go type in 100, my angle of 100. I'm going to hit this second apps for angle. And I'm going to type in number 1. For degrees. So I've typed in 135 degrees. When I hit enter, this is going to convert this to radians for me. So 2.36, and we put rad for short for radians. Okay? All right, so let's do 180 degrees. Okay, and the reason why we're doing this is we're trying to learn something about the relationship between degrees and radians. Okay. So 180 degrees works out to be 3.14 radians. Okay, and then finally, if we did 360 degrees, 6.28 radians. So something that we should be recognizing here is 3.14 is technically the value of pi. And 6.28 is technical pi. So the conclusion that we should be making is technically when we talk about radians, radians is actually a relationship in terms of pi of our degree angles. So in conclusion, 180 degrees is equivalent to 1 pi radians. So remember, pi is a number. It's just like 3.14, but we use the symbol pi to represent that number. Okay, so convert the following to degrees to radians as exact and rounded to the nearest hundredth. So we want to give it an exact value, and then we're going to round it. So we already know the value of 180 degrees. Well, 180 degrees is equivalent to pi radians. So that's an exact answer. Rounded answer would be 3.14. All right, if I wanted to convert 45 degrees to an exact value in radians, our calculator will not do that. It'll always give us this decimal, never-ending decimal. And so we want to actually write this in terms of pi. So how are we going to do this? Well, we're going to just set up a simple cross-multiplying ratio. We know 180 degrees is equivalent to 1 pi. I want to know what 4 is equivalent to in terms of pi. So I would cross multiply and then divide. So 45 pi divided by 180. So now I'm just going to simplify this fraction. Okay, so you can either do it in your head or you can actually simplify that fraction on your calculator, excluding the pi. The pi is going to be part of our answer as an exact value, so we're just going to simplify that fraction. So I'm going to go 45 divided by 180 on my calculator, hit enter, change that to a fraction, and my simplified fraction should be just pi over 4. So my exact value in radians would be pi over 4. And then as a decimal, then I would actually divide these values, which is 0.79 radians.